Hello, everyone. Thank you for joining. So my name is Filipi, and today we're going to talk about discovering CNC in malicious PDF using some techniques like obfuscations, encoding. So here my contact on Twitter, @Filipi, and here we have some contacts about me in my projects in the GitHub and LinkedIn. And here my webpage, if you'd like to see some projects that have been working there. I have some talks that I have been participating in some events. I having articles there. So just some informations about my project, right? So let me introduce myself. Today, I'm a principal security engineer at Talkdesk. Talkdesk is a company from Portugal, by the way, and responsible to sell some contact center as a services. But my focus there is to work with a security in with the product, in the environment. And I'm security research at Senha Segura. Senha Segura is a Brazilian company. And by the way, I'm talking from Brazil now, here in São Paulo. And Senha Segura, it's a company responsible to provide a PAN solutions, a privileged access management. But my role there, it's made a research and presenting these researches in some conference. And this company appears in many different reporters like Gartner, Foreigners, and Coppinger-Coley, and so on and so on. And I'm advocate of the Hacking is Not a Crime. It's an awesome project. The focus in this project is talk about the hacking, because it's hacking. It's really a mindset. It's how you can, look into the same software. So how you can look into more deeply and how you active your creative mind. So that's the idea of the hacking, right? So it's not a crime. So when you talk about the cyber criminals, it's a cyber criminals, not a hacking. So this is the idea of this project. And I am coordinator of the staff team of the DEF CON group here in São Paulo. It's a big community here. And I'm instructor of the hacker security. I have our HackerSec. I have a course of the malware analysis in Portuguese language, of course. And I'm instructor and writer and reviewer in this 3 magazine in Europe. And by the way, I have some courses about the malware attack with a Q-chain strategy, right? So in the Pentest magazine, and that's some information about me, right? So let's talk about our main topic today. And first of all, I'd like to put all those people in the same page. So I would like to explain more, just a simple definition. So what is a threat, right? So it's not definitions from Filipi, it's defined from this ISO. It's defined as a potential cause of an incident that may cause harms to the systems and organizations. It's really important you understand that because we're going to talk about the malware, right? So what is correlations of the malware and threats, right? So in this case, the threat is more related to a software attacks, or maybe a theft of the intellectual property, or identity theft, or sabotage, or information distortions are example of the information security threats. It's just a simple definitions, but if you see here, you can see many things is related to a software. So how you can explore this software. So, but of course, remember it's related to a potential incident, right? So when you have some threat, you need to investigate more that, you need to look in more deeply about that, and you can see about the behavior. So because of this, important you understand what is exactly a threat, okay? So let me explain more about some steps about if you would like to use in the malware analysis. So the first step is you need to identify or the identification steps about the artifact, because you don't know if it is malicious or not about the sample. You have a sample, right? So you have an artifact. So maybe you can find some malware, malicious software, or maldoc, malicious document. So this is simple definitions about that. So the identification step, it's a pretty important step when you need to perform something related to a malware analysis or malware hunting, or another name of threat hunting about the threats, or a SAM binary, okay? So after that, you can choose what the best methodology you can apply this if you use in statistical analysis or dynamic analysis. So my recommendations to you, it's always to using, when you perform some analysis, you need to produce something, right? So you need to have something touchable, okay? And because of this, you need to produce some report, because this report, you can present this to some coordinator or some manager or whatever. But when you register these informations, you can look in more deeply about that, and you can improve your skills, because you need to register all those steps that you perform in these analysis, okay? And this is very important. So then after that, you can improve your defenses mechanism. Why? Because when you discover what is exactly the path during this analysis, you can improve your knowledge and these defenses mechanisms, your security sensors in your environment, your organizations, okay? This is a very important. So another point is you can build in the cyber threat intelligence. You can create this intelligence in your company. Even in your company, it's big or small, it's not a problem. You have many different tools to help you in how you can create this cyber threat intelligence. Why it's important to create that? Because the threats are changing all the time. So we need to strengthen the cyber resilience. It's a good word, right? Resilience, but basically you need to improve that because the threats are changing all the time. So let me explain some simple definitions about statistical analysis. I don't have a time to explain more details about that, but it's a simple explorations about the malware analysis. This usually is the first step in the malware studies. Why is the first? Because usually the statistical analysis describe the process that you analyze in some program code, or maybe the structure of this code, or maybe if you find some functions imported by the DLL inside of this binary. So you have a binary, you have inside of this binary, you have some DLLs, and these DLLs have some functions imported. So you can look in more deeply about that, the statistical analysis. So maybe you are thinking about, so Filipi, when you will talking about the reverse engineering. Reverse engineering is part of technique that you can use in the statistical analysis and dynamic analysis. You can use in both of them, okay? But it's a technique that you can apply in this methodology, okay? Because when you using this reverse engineering, you can looking more deeply about the some DLL, as I mentioned, but you're looking more deeply to see in assembly program language. So how you can look in this process work is in the background or in more in the low level actually. So in this case, you're looking more deeply to using to the reverse engineer. But I've been talking just a concept about the statistical analysis, okay? And the program in this case, it doesn't run in this time. And of course, it depends of the program because you need to use in some programs. So if you run the program, you will using another methodology, but just to clarify that, okay? But usually this process, it's more safe, okay? Because you doesn't run the binary in this time. You can look in the behavior, not behavior, you can look in the some characteristics inside of the binary, some functions. And of course, you need to understand more about the functions, the DLLs, the libraries, and something like that, okay? On the other hand, you have a dynamic analysis. In this case, it's only or solely on behavior analysis, okay? So you will looking more the interaction of the malware has when the malware itself is executed in the environment, okay? So in this case, it knows not like a runtime analysis because you need to run the malware, or in this case, you don't know if you're malware or not. You run the binary in the some environment and you see the behavior. And this is the dynamic analysis. Remember, when you talk about the reverse engineer, you can look into this and some tools that can help you in this dynamic analysis, and you can see the reverse engineer. But again, it's a part of technique using in both of them techniques. So of course, it can be easily automated, this dynamic analysis using some tools to help you. One of these tools that you can use in this concept, it's called sandbox, when you have some controlled environment with a virtual machine, and you can pick up this malware and you can perform it or run this malware or this sample inside of this virtual machine, and you can see the behavior. But understand the point, it's very important you understand is when you execute this in sandbox, you need to have some engines right inside of the sandbox. Of course, you can create your own virtual machine, but you can execute the malware inside there. You can just, you can see if it's infected or not, but you don't have any engines. But when you're using some sandbox to the market, App Annie or Joey Sandbox or another different services, they have some engines inside of the sandbox that you can see, or maybe you can use it, for example, Dragfoof. It's a pretty nice open source sandbox tools. They have some engines inside that, and then when you perform that, you can run in some analysis. And by the way, if you have some doubts about this kind of sandbox in open source or not, you can send me a message and I can send you the link to you, okay? So just a concept. Okay, let me talk about before to talk about the physical and logical structure, I would like to present you some important thing about this basis, okay? Remember when I talk about the information in steps, the identification in steps, when you need to understand it, when you receive some sample to execute some analysis, like me here, I have some samples here. I have the Amazon, I don't know what exactly is this kind of file. Invoice PDF, maybe it's a PDF. So I have here malwarehunt.python, probably as a Python, resume.pdf, just as a simple document. Okay, so I can just execute the file command. It's a tool that can help me, okay, to identify this kind of file. So let me check here, Amazon. So we have here the basically Amazon Microsoft Word. Okay, it's a Word to investigate more about that. Okay, let's check another. We have here let me check here the PDF. So no CD, it's a file, resume, no resume, it's lowercase, resume.pdf, it's another PDF. Okay, let me check here this malware hunting. It's a good name, maybe it's a malicious. Okay, file malware hunting.py. In this case, it's a Python script. Okay, it's totally it's a sample, it's a malware. Okay, so but my point here, we need to understand those bases. So how I can improve my bases. So that's my point here. It's very important to understand something. So what is exactly file? Determine file type. But here we have a good key important. So how the file works in the background. In this case, you can see here the concept. So the concept of a magic something. When you execute this, they have some magic something called what? What is magic, Filipi? In this case, this file have a magic number. So the explanation is all those binaries have a magic number. What is exactly a magic number? Is a storage or it's a something? Because if you don't know, it's a something stored in a particular place near the beginning of the file that tells the Unix operational systems, okay, that the file is a binary executable. So this is identification of the binary. So this is a way has a file tools that I am executing here works. So when I execute this, they have something inside of the Unix platform. If you see here, take a look at this. The information identifying this file is ready from atc-magic /dash magic, and the compiled magic file is in this place. So you can see this, that you have the tools inside of the Unix platform compiled, as we can see here. So when we execute this, we can return, you can receive some information about that. So when you perform it, when you execute, when you run the file command, this command execute this in the background and show us some information about the file. But so let's see some important thing here. So let me using the malware here, and let me take this. I have here, let me cut here, for example, and I will put here another different thing here, like %pdf-1.9, for example. Let me save here, and let's see what happened in this case. If I use into the same file here, take a look at this. So now I don't have more a Python script, as we can see here below. It's not a Python script. So now we have a PDF document version 1.9. Why? Because I'm manipulating the magic number in this specifically file. Okay, that's a good point here. So I have here, for example, let me show you. File, it's a magic and magic. I will have here all those databases of the magic, the file. So here I downloaded basically from the Debian platform the source of the malware, and here the source of the file. And here we have many different many rules related to some binaries. Like let me show you here, like a JavaScript, for example. Let me go there, some JavaScript, just to show you some information about that. So JavaScript, and take a look at that. So here, if you see in some information in the beginning of the file, for example, here I have some important thing. So let me copy here. And if I return here in my root and malware, so let me change one more time this file again. So let me cut here, and I will pass here. Let me save, and yes. So if you see here, take a look at that. So now I have a Node.js script. And if you see here, I have a JS file executable, okay? Because I'm manipulating. So how I show you here in this file, this is the database, okay, and how the file works in some rules inside of that. So that's a pretty important you understand all those steps and all those bases, okay? So because of this, I would like to explain to you how important it is you understand about those bases, about the file, about the strings, and something like that. Remember, this is the first steps. It's not a reverse engineer, okay? Just to clarify, but you need to understand to see some characteristics, like, for example, if you see here in the Windows platform, I have here some files in Windows. For example, let's check here. I have sample and I have IOs. So if I'm using strings -a, because I would like to see all those informations inside that, I using pipe to grab some informations about what, some expression regular about the DLLs, okay? So I'm using strings to collect some informations, -a to see all those informations. I'm using grep to select that some strings using the expression regularly. The name of the expression is DLL, okay? If I execute this, let's check what I found here. I need to set the file, right? I forgot the file. Let me put in the file here. It's a whois, okay. It's a binary. Let's check here. Yes, it's a whois. It's not here. It's returning here, -a. It's a whois, and okay. So now I have, we have DLL. Take a look at that. So this is all those DLLs that I have inside of that. So this is information that you can find using the strings command. So how strings works exactly? So sometimes when you executing some string don't appear to you in the command. Why? Because if you see here in the man of the strings, Filipi, I don't like to read it man. I don't like to, but in our area, we need to read. So take a look at that. So the printing the sequence of the printable characters, okay? And here we have the important information. So strings print the printable characters sequences that are at least 4 characters long. So take a look at this important thing. So because of this, when you execute the strings, you didn't see the MZ signatures or the PE signatures in the binary when you talk about the PE, right? So because of these simple explanations, but we need to read that. We need to understand that. You understand, okay? So let me return into the presentation. So let's talk about the physical and the logical structure of the PDF, okay? So the structure of the PDF, in general, we have 4 mainly parts in a PDF. The header, okay, the body, and the cross-reference table or X table, and the trailer, okay? So this is the 4 parts that you have in some PDF, the structure of the PDF. Usually you have here the version in the beginning, in the header. It's pretty common in many different binaries, okay? Inside of the body, you have more, funny things, not funny things, but like a pages, emoji, font, or bookmarks, not many important things. Understand me, the double quote here. And the cross-reference table is important thing because it's the locations of the object within the file, and for a random access, I mean, all those objects is access referencing is another kind of object inside of the same PDF, okay? And we talk about the trailer, we have a locations of the certain objects within the body. I mean, it's if you see here, all those trailer and cross-reference table is linked in each one, okay? It's pretty important. So let me show you the demo here about the sample that I received to analyze, okay? Just a PDF. So when I receive this PDF, I need to see exactly what is this sample. So we have here the PDF, the CV, like a resume, okay? So it's pretty common, every company receive nowadays, okay? So first of all, to see if this PDF is sample is PDF or not. So I'm using the file again. And after that, I'm using PDF ID. This tool is created by DJ Steven. And by the way, there's pictures about the structure from DJ Steven's blog. So as you can see here, you have a 15th object. You have some strings, in this case 2, and you have 5 JavaScript, as you can see here. So you need to investigate more that, because if you have 5 JavaScript in a PDF, so it's for my opinion, it's totally malicious, okay? Because usually you don't have any JavaScript inside of a PDF. And you have here the open action. So Filipi, what that means open actions? It's a simple explanation. This is a functions when the PDF has the user don't need to click it. The user don't need to interact with the file, okay? The only action the user needs to execute is, for example, if the user received by email, to download the sample, or if they have in a server that someone uploaded this CV or this resume, okay? So when this resume is uploaded to the server and the storage of the server, the user don't need to click again, okay? It's a simple. So because they have this open action function, I mean, the file is executed itself with no one actions or interactive of the users, okay? So it's pretty dangerous because the user don't need to click to execute, okay? So let me see more information. So I see that they have 5 JavaScript and they have an open actions. So after that, they're using the PDF parsers, another tool from the DA Stevens, to see some information about the PDF. So my idea here is to see, to find something more deeply about that. So I see here about the JavaScript. So I use /s to search about the JavaScript. So as you can see here, we have 3 references here in an object 7, and object 1, and object 12, okay? Because when I execute the PDF ID, I see 3. So if you see here, I execute the JS, and as you can see here, 2 new reference, object 1 and object 12. So we have 5 JavaScript. So this is slash is a part of the content inside of the PDF, and as you can see here. So let me explain something here. It's just to think you, to give you to bring you some thoughts. Probably when I'm supposing, of course, but probably when DJ Steven create these tools, of course, he investigated a lot and many different PDFs, and probably he found different informations like open actions or not open action, like a JavaScript encryption informations, or maybe some automated automations or automaticity. Automatic is not the correct word, but some words or some characteristics of the PDF, they found something, and because of this, they create this kind of slash to identify and to see more easier for us to see about this information in the PDF. So when you, for example, try to create some tools to help you, to help the community, it's very important you see about that, the behavior, understand the behavior of the file, and after that, you can create your own tool. And this is a pretty nice. Because of this, it's very important you understand those bases, okay? So it's because of this, it's easy to identify this information. So, okay, so let me explain more about the PDF parser again. We'll see some informations about the run output, because I would like to see all those run data inside of this PDF. So I execute the PDF parser -w, it's in this case, it's a run, okay? And I set here the PDF and pipe less because I'd like to start in the beginning of the file. So first of all, we have the object 1, and take a look at that. We have a 7 reference here. I mean, in the object 1, remember in the explanations about the cross-reference table, is referring, okay? And take a look at this. We have an open actions. It's totally linked with the JavaScript. So here we can understand here that you have an open actions. Remember what is an open action? You don't need to click again to execute something, you just need to download the sample or uploading from the web server, for example. And after that, the file will execute itself, this open action, but the file will execute the JavaScript. As we can see here, this open action is totally linked with the JavaScript, okay? So that's the point here. So here you can understand more information about this behavior, okay? Object 2 and 3, remember we have a 15, and take a look, there's another reference. Object 4, we have a more 2 new reference, 8 and 9, but we need to see about the 15 objects, okay? In object 7, we have another reference, object 10. So we have 10 objects reference. So in the object 10, we have a JavaScript reference. Object 8, just information about the image reference. Object 9, you have a more other new reference. Object 11, take a look at this, all those objects, it's linked in each one, okay? In object 10, we have here the JavaScript, remember? And another reference, object 12. Inside of the object 11, we have the first streaming. So usually the attacker, when he would like to put some malicious code, they like to using some string to compress something inside of that. So because of this, we have this streaming. So here, maybe I could investigate more, because I have here the streaming and I have here the some function flat decode. So when you have this information inside of the streaming, it means that you need to decode something. Basically, we need to decode this streaming. The left is it's the size, right, of this streaming. Basically, it's a simple explanation. And inside of the object 12, we have another reference, object 13, and take a look that we have the JavaScript inside the object 13, but we have the streaming in the size, it's bigger. It's different the first. Remember that? So probably this is the main object that we need to investigate more deeply, because the size is it's high when you compare it with another, okay? And so I just writing here, and I write, by the way, wrong. It's not a mailing, but a main point to investigate. So, okay, let me looking more deeply about that. So I have another tools to using here in this investigation. It's a PDF TK. It's another tool, but this tool is not from the GE Steven, by the way. It's a tool to manipulate some PDF. Okay, all those tools that I'm using, as you can see here, I'm using from the Debian platform. Okay, or in this case, it's a Kali Linux. Okay, so this is some information that you can use in this platform, and I will using this. The specific function here is the functions about the uncompress, because my idea here is to uncompress all those informations inside of the PDF. Remember, not the PDF, but not only the PDF, but mainly in the PDF, in the object 13. Remember, because I have there the big size of the streaming. Remember, in the object 13. So okay, execute this. I set the output in this name called I send the output to the dump.txt, and all those informations are inside of that. So if you see here, take a look what I found here. The streaming, this obfuscate here something, not this obfuscate. I using the flat decode. I decode this information. So here is the first technique used by the attacker. So here we have the JavaScript, but the JavaScript is using the obfuscation technique. So this is the first technique using by the attacker. They're using the JavaScript obfuscated, to difficult the analysis from the researchers or the more analysts or something like that. So first of all, when I edit this this JavaScript, take a look that we can see here some standard behavior, right? So we can see here the letter and the numbers and percent here, and then something different color, but we have here the evil parameters. So I try to manipulate something in these evil parameters, because if you are talking about the JavaScript, so probably we have some web applications or some web pages related or related to this, right? And because of this, I created this sample doc HTML, because my idea here is to publish this JavaScript in some browser. This is my idea here. So I'm using this evil parameter to change this parameter to a document write, because I'd like to print this information to obfuscate this JavaScript in the web page. Of course, I'm using some comments here just to help me in this demo. And I use this evil parameter to change, just to show you. And I save the file here. As you can see, I need to give the permission to access this this page, this file in a web browser actually. And after that, I can execute this sample in some browser to open in this browser. Okay. So let's see what happened here. Execute this in the Firefox sample. So let's see what happened now. And if you see here, I'm open the browser and take a look what I found here. I found the payload, variable payload. What that means, payload, Filipi? So if you know what is payload, no worries about that. But if you don't know, you explain more about that. Payloads is a part of package responsible to to downloading the victim machine, and this specific package is responsible to return a callback to the CNC or command and controller from the attacker. So this JavaScript has an exploit, and this exploit is responsible to download the payload, and this payload is responsible to call back the CNC. So let's see. First of all, inside of the PDF, we have a JavaScript with a exploit with a code, and this JavaScript using some obfuscation techniques. And after that, this JavaScript will download the payload inside the virtual machine. So take a look at this, the percent, letters, and numbers. This is a standard behavior, standardized, as you can see here. So this is maybe interesting for me, okay? So I need to, when I see that, I can finish because it's totally malicious, the file, but I saw that, and I tried to investigate more about that because I saw more information, and I tried to investigate more, okay? And of course, we can agree with me, this sample is totally malicious, okay? So the idea, if we try to understand if the sample is malicious or not, it's totally malicious, but I continue to investigate to try if I found some another informations, right? And so now I have here the payload, right? So this is the package, or the information package, the informations about this payload, okay? Because we see the variable, remember that var dash equals payload, var equal payload, and I copy that and I pass here in this payload file. And after that, I use inside to cut this percent, to cut this behavior, as you can see here. So here we can see another techniques using by the attacker is Unicode techniques, to using what? To encode some informations inside of that. So I basically now using this, I copy this code to generate a new file, and this file I called, it's not EC2 as EC2 actually. It's an old version of the UTF-8 because the evolution now it's a UTF-80. So this is old, okay? Just to explain this another technique. So the attacker is using what? Using the JavaScript obfuscated. The second, they're using the payload to download in the virtual machine, and they're using the EC2, and it's not an E2C, it's EC2, the correct name. And if I remember, it's EC2, but I will show you, and this is another platform in the Windows now, is EC2 to encode. So here I will explain the same file, but now using the Windows machine, because probably if you are thinking, Filipi, I like it to using Windows, I don't like to using Linux. I don't know why, but no worries about that. I will use it in the Windows platform to show you another possibility, okay? So as you can see here, I download the same package, okay? The dump dex and real payload. I copy this, and I will using another platform called Mozilla, as you can see here, okay? So I will pass here this, and I'm using, let me just pause here to explain. I will copy, I pass here the same code, as you can see, the same standard behavior, percent, letter, and numbers. I passed here, and I using ECS2. We have the S, ECS2, okay? So this is the the old techniques using by the, it's a different way, because again, the evolution is UTF-8, okay? So I pass here, and I will using to encode this to generate a new exa file binary. Why I do that? It's a simple, because usually the malware is executing in the Windows platform. So because of this, I generating this exa binary file, right? Because my idea here is to execute this file in the Windows platform. Because of that, I generating this exa file binary. So I generate, and I call them CNC doc binary, okay, or doc bin, as you can see. And I use here the DA Steven suites. If you can use in this platform, this many package of the tools we can use in the Windows. And I'm using one of this another tools called the Shore, okay? And I call the binary, and I set here the protocol, okay, to try and find some informations about that. So take a look what I found here. Wow, the command and controller from the attacker. It's a simple, okay? Remember, this is a payload. Inside of the payload, it's a callback from the CNC, the attacker. So here is the IP from the attacker. And this attacker, in this case, it was in Estonia, Europe, right? So if you I put here some some information about that in the VirusTotal to see about some engines. Okay, it's clear in some engines, but in the first point, for example, it's a malicious. In the commode, it's suspicious, and it's from Estonia, by the way, here. And if you see here in the community, and I can explain more about these engines, but the idea here is just to explain more about the information related to this specifically main IP address, okay? And it's not new, it's old, as we can see here, okay? And we have more references here about the some URLs using. And if you see here in the community, in the details, now in details actually, okay. So here's, as you can see, the victims to exploit sites, and you can see here that using a malicious PDF to attack an Adobe Reader plugin, as we saw in these presentations. Okay, so here I would like to, if you usually in the conference, the people asking me about some recommendations, I can recommend these awesome books if you want. It's Mastering Malware Analysis and Techniques, and some malware techniques and malware threat hunting and practical related to threat hunting. And don't forget, hack the planet always, okay? And if you have any questions, so please let me know. My contacts again, and then thank you for joining one more time. And if you have any questions, so please let me know.